Okay, here we go again. So you have taken your first render, you have created your first 3D animation that officially makes you a 3D artist, and you are well on your way to becoming a professional. But I think that what makes the difference between a hobbyist and a professional is a certain amount of technical knowledge and expertise. So you might very well become well versed in Blender and know everything you need to know about, the commands of it. But Blender is part of a much larger picture. And so I want to teach you a little bit about the history of 3D modeling and its evolution, because one key concept that you need to get is that 3D modeling is a field that is constantly evolving. It's changing. And so you will have to stay up to date. Things that you can do today, 2 years ago, you couldn't do because 3D modeling as a whole field was not there yet. And so to know about the history of it, I think is important to have a solid understanding of the context in which you are working. So when we talk about 3D modeling, when we talk about 3D graphics, we are talking about mathematics. Although it all happens in the background, under the hood, it's all about visualizing information, and that information has to deal with geometry and mathematics. The first thing you should know is that 3D modeling, in fact, is kind of a umbrella term. It only refers to the broad field, and what we've been seeing in Blender so far falls under polygonal modeling or poly modeling. But there are other ways of 3D modeling, other types that leverage different forms of mathematics. There's digital sculpting, there's curve modeling, and so on. Now, the OG of 3D modeling are NURBS. NURBS are a way of 3D modeling that is based on curves. And NURBS stands for non-uniform rational B-Spline, which is a very long name, so everyone calls them NURBS. Now, NURBS are at the foundation of what is called computer-aided design, which became known informally as CAD. Now, the history of it goes about something like this. At one point, we didn't have computers, but still we needed to design things like ships. Now, ships have hulls, and hulls have a really complex 3D shape. So the people that were in charge of creating those hulls, the shipbuilders, helped themselves with drafting tools, with all sorts of tools to be able to draft and create the large drawings with which they would design the hulls. Now, those large curves, smooth curves that define the 3D shape of a hull were achieved with the help of a tool called Spline, which was a thin piece of wood that was very flexible, and it was kind of held in place by things called ducts. So originally, the spline was an actual piece of wood that the draftsmen, that the shipbuilders would use to draft their design. Now, around the 1950s, mathematicians started to study splines more, and eventually they derived a polynomial formula for it to precisely define spline curves. In fact, the name spline curves was given by a mathematician by the name Isaac Jacob Schoenenberg. Now, fast forward a few years, and computers were invented, And in France, people started to wonder how they could introduce computers and splines into the manufacturing process of cars. And if you are passionate about car design, you will know that throughout the decades, the design, the style of car has changed. And if you look at cars in the 60s, they used to have very soft and rounded bodies. And then if you look more into the 80s and the 90s, they started to look very squarey and like wedges. So why is that? It is because the tools that are used in the industry to design those objects have evolved over time. Now, in the 60s in France, there was this pioneering work being done by an engineer by the name Pierre Bezier at Renault. And at the same time, there was another guy called Paul de Castelgio at Citroën that they both worked on the same thing, which was to figure out how to introduce splines into this process of making cars. But Bezier kind of like was the guy that publicized his work a little bit more. And that's why those splines became known as Bezier curves. And now in every single software about 3D graphics or 2D graphics, whenever you have a spline, it's often referred to as a Bezier curve. Cool. So since we're not really gonna be modeling in NURBS, I think that this is about everything you need to know about NURBS, other than the fact that NURBS were used to design the Utah Teapot, which is kind of the first 3D model to have ever been made. It's like the hello world of 3D modeling. And it was created by Martin Newell in the 70s at the University of Utah. And that's why it became known as the Utah Teapot. Moving on, we can start talking about polygonal modeling, which is the actual thing we are learning with Blender. And as you have learned in the few previous videos, the most basic object in 3D modeling with polygonal modeling is the vertex, which is a point in three-dimensional space. The moment you have two and you connect them, you have a straight line and then you have an edge. And then when you have three, you have a triangle, which is the simplest polygon possible in Euclidean space. And then if you keep going up, you start to have quads, right? So four-sided polygons. So threes for triangles and quads for four-sided polygons or squares are the most common element that you'll come across in 3D modeling, and it's what defines the faces, which is what you usually see when you look at a 3D polygonal model. Now, we don't need to go deep into the geometry or mathematics of it, but what we need to understand is that working with polygonal modeling means that you are basically connecting flat faces. And that's why they suck at representing curved things, because you're always making an approximation. You cannot really make a circle with it. You can only make straight edges, and then if you have enough and they're small enough, they look like a perfect circle, but it's always an approximation. And so that's why when you have curved objects, polygonal modeling can become computationally expensive. But the kick is that actually polygonal modeling is the best way to go about organic shapes. So NURBS are used more in the industry of manufacturing things, especially at scale. However, when we look at 3D graphics for computer games, VFX for videos and movies, most often we are looking at polygonal modeling. Okay, and I think that this is good enough of an introduction to the evolution of the technology of 3D modeling and 3D computer graphics. You don't need to learn it all at once, and I guess we can wrap it up and move to our next phase of learning Blender.